So the plan is to mount this Doka pole. It's a 30-foot extension pole to the RV for the solid RF cell phone booster system. I wanted to put a booster in the RV so I can do email and we can watch Netflix and whatnot, even if we're, you know, away from civilization. So this actually extends 30 feet, if you can believe it. So I plan to mount it on the ladder here and then run the wiring underneath the RV, and we'll see how that goes. I think it's the most economical and practical way to put a aerial basically on the RV, and this gives me the ability to go up to a crazy height of 30 feet with the antenna, which I mean should give really good signal even in areas that there's really low cell signal quality. So to mount the pole, I'm just going to use this, it's a pole mount. Of course the threads are a little bit too short, so I'm using this as a standoff, so I might add a proper standoff on that after. But basically a split washer, this wing nut, and I'm going to put red Loctite on it. It's also going on some of this foam material, which will help absorb some of the vibration. So, but it's basically going to go right there up that side, secured with three sets of those mounts. All right, so I've got the pole mounted, and just so you can see how high it can go, I mean, it's really high. And that's not even fully extended. I think it gets a little bit too wobbly. I'll have to see in the wind whether to use that thin top section or just the thicker lower sections. But I mean, that's a pretty high antenna. The antenna sits another 2 feet off of that on the top. So anyways, there'll be coiled wire running down it all the way. And yeah, so I think that went pretty good. I think that's a really good way to have a super high antenna that you're not messing around. I mean, that's a lot of antenna height. And when it's all folded up, it basically you can't really tell. I don't know about these clamps that I used. I don't know if I like the look of them, but what I might do is just trim this material off. I don't like it hanging. I mean, it doesn't get in the way of your ladder or anything like that, but I mean, it's looking a little bush league looking wise. So maybe I'll try to find some little better clamps. But yeah, it clamps on really tight. It's nice and level, and you can see it has these little clasps to hold each section. Yeah. So mast is in place, and then it butts down on the bumper, so it can't, you know, fall through itself. So I'll have to check vibration wise, split washer with wing nut with red Loctite, if that's going to be enough. If not, I'll have to put Nylox on it, and then it will, you know, it'll never come off that way. So yeah, I'm about to do an install of a solid RF cell boost system onto my RV. And this is the mount that the solid RF comes with. I'm not sure the pitch of the thread on the base of the antenna mount, but the antenna sits on here, it gets threaded in, and then the RF cable comes out there. And this is the mount that you have to mount somewhere on your RV. That's great, but my plan is to use a extendable pole similar to a painter's pole. I'm going to mount it to the ladder at the back of the RV that I can extend up to 30 feet. I'll probably need an extension cable. And this is just the painter's, it's a painter's extension that goes on the end of any kind of painter's pole. And the thread, actually the inside thread, not the outside thread, but it's not even threaded, but the inside diameter of this is extremely close to the inside diameter of this. So my plan is I'm going to just slightly ream it out, and then I'm going to thread this into this hole, and then epoxy it in place as well. Maybe I'll heat shrink it in as well. But the antenna is so light that I think that is going to be more than strong enough to be a great mount system. Plus, this angles down, so when you're traveling, you could have it angled parallel to the RV as well. So it's out of the way. It can't get hit with anything. Anyways, I'm going to try that. If I screw this little painter's thing up, it's no big deal. You can find these at any hardware store. But I think that would be a really slick way to mount this. We'll see. Yeah, so basically I just reamed that out and then threaded in the metal rod. And it looks like the plastic just got threaded itself. It kind of made its own threads because it's a much softer material. So I'm going to thread it all in and see how it goes. So there we go. There's the mount mounted to the basically a painter's extension. Bored out, threaded in, and then I put a little bit of heat shrink on the outside just to clean it up a little bit, make it look a little bit prettier. Anyways, I think that'll work pretty good. It's in there really strong, so I mean this whole material here would have to break for the antenna to come out. I was going to epoxy it, but I think that's overkill. The thread strength to actually screw this in was pretty strong. I was actually worried about cracking it. So I think that's going to be really good and work really well. We'll see. I'll show you the final install as I go along on how to install the cell phone booster. So I have a little test bed set up here for the solid RF cell booster. Basically, my interest is how much signal degradation is there when adding multiple cables in line with each other. So what I did is I have my antenna up in my hallway here, like it would be on the RV, and then I have the solid RF booster, and then these are the black cables are all the stock cables that came with the unit, but I needed longer obviously because the antenna I had the antenna pole. So this is a 30-foot cable of RG6, which is a 75 ohm coaxial, shielded coaxial cable with F-type 75 ohm connectors on the end, which is what the solid RF cell booster uses, at least on the unit. On the antenna itself, it looks like it's some sort of 75 ohm SMA connector. I'm not sure the exact connector, but this cabling is in fact 75 ohm and it uses a F-type connector, which is very standard. My problem is that with all the stock cables, there's 3 of them. When you start adding all of them together, you have all these different interconnect points, and all these different interconnect points should introduce, not interference, but should introduce a what's called VSWR, voltage standing wave ratio. It's a loss of signal just because interconnects between the cables, dissipate the energy basically. So, but I have done tests, and I can't show you because I'm filming with my cell phone, but you basically download a LTE Discovery app, and it shows you how many decibels of signal you have. Now, in my house here, I have really poor signal. I'm at negative 118 basically, and I've did all kinds of tests. I'll do it on a little chart, but basically, directly the antenna plugged into the unit, the antenna plugged into one cable, 2 cables, or in fact 30 foot of cable had almost 0 change in dB. I was sitting at negative 118 dB, which is a poor cell signal in my house. And when I plugged the solid RF cell booster in, I was getting negative 81. So that's almost a 40 dB increase in signal, which is huge. It's a huge increase. So this thing actually works. So that's number one. And it seems that having this 30-foot cable has 0 to negligible impact on the signal quality. So I'm going to be able to use that. So that's what this test was for. And for curiosity's sake, basically, just as a test, I plugged in this whole conglomerate of wires together. So the stock, the antenna wire, the 2 jumper wires, and then I just tried for an experiment plugging in the 30 feet of this RG6. Now we're kind of really mixing and matching wires and cables. It's all the same impedance, of course, but and the results, okay, so there was degradation after I installed all of them together. Basically, instead of gaining 40 dB, I'm gaining 20 dB. So there is degradation by adding too many cables in line. That was just an experiment. Of course, I'm not doing that. I'm just using the one antenna cable and this white RG6 cable, so it's going to be negligible, but I just thought I'd say that. Installing the solid RF cell phone booster. So basically what I'm going to do, there's some 12 volt wires here that go up to a charging plate for cell phones there. And since it makes sense to just keep your cell phone charged, and then I have the internal antenna for the booster just tucked underneath the wood so you can't even see it. There's only, you know, a 1/4 inch of wood to go through there, so it shouldn't be a problem. It's going to go down here, down here, down here. This is going to be the leads for the RF booster. It had a CLA connector on it, but I just cut that off, and I'm going to hardwire that with T-taps into the 12 volt positive and 12 volt negative supply. And they're going to go down here, and this is where the and this is where the RF booster or the cell booster is mounted. Basically, for power right now, I'm just going to pull the little the plug out of the top. I'm going to have to put a switch in at some point, but not right now. So this is the bottom lead for the internal antenna. This is the top lead for the external antenna. So that's the way it's going to go. It's in a relatively useless spot in the RV, excuse me, and is out of the way, and it's perfect for the signal to send the Wi-Fi to the TV. Alright, so what we did is we just T-tapped into the positive, T-tapped into the negative. If you've never used these T-taps, basically what they are is an easy way to tap into existing DC power. They come in a little kit like this of all the different wire sizes, so you have the actual tap, and what they are is what's called an insulation displacement connector, an IDC connector, and this little metal blade digs into the wire, and then it holds it on like this, and then it's kind of neat that on the back end where this little hole is, the other portion that allows you to crimp and then just attach a wire. So it's super handy for doing stuff like this where you don't want to start redoing all the wiring. So I'm just going to, I also added an inline fuse. This solid RF unit draws 1.5 amps total. I don't have a 1.5 amp fuse, so the smallest one I had was 3 amps. So if there's any danger with a short, then it'll blow a 3 amp. But I have a 1 amp fuse, but then it might blow just from the draw of the transmitter. So yeah, so that's what we're doing. I'm just going to tuck all this away, power test it up to make sure it's working, and go from there. So the power assembly's plugged in. The green light is green, so it's got power. None of the lights on the unit are flashing, which would mean it's in a state of oscillation due to too close of a proximity with the external antenna, so that's not the case, so it looks everything is good. So this is where I'm going to drill through the coaxial cable. Basically, these are the low point drains in the RV, and there's a lot of space between them. I'm going to drill a hole right in the middle of them and put it between that, just because I know there's nothing underneath that, because there's already 2 of these penetrating. Then I'll put a grommet and seal it up with foam after, so I think that's a great spot, and it's out of the way. So there's the final install. It's all tucked away, powered up, just wired along the side there, and that's where the wire's going to go. I'm going to put some silicone down in there and then screw on this grommet. Really good results. Basically, it went from negative 112 to negative 69, so that's a huge increase in cell signal. So I'll show an outside pic of the final mast with the wire up. So there's the final install, basically extended, not fully extended even. There's still another 10 feet of cable that can go up. So that's using 2 of the 4 extensions. So you can see you can get really high, but I think this is the most stable position that you could have with the 2 largest extensions out. And basically to hold the cable while traveling, just use some gaffer tape and a hose, small hose reel that you'll just wrap around that. And then there's a clip-on Velcro section to clip onto that, so even if that's, so it can't unravel while you're traveling, basically. But yeah, I think it turned out really well, and it's a huge improvement in cell signal. I went from the interior from negative 112 to negative 67, so that's a huge gain in dB. It's when with cell signal, it's the more negative the better, the less negative the better. So yeah, so it really was great. And here's the antenna in its stowed position. This roof ladder protects it from any sort of hits, so, and it just extends over the back slightly. There's the levers for extending the pole, and then it just comes into a very simple cable reel. And then for safety, it's got a Velcro clip to this the metal there, so in case this falls off for some reason while you're driving, this doesn't unspool and it creates a big hazard. So yeah, so double safety there, and yeah, turned out really good.